I really like related rate problems and I love optimization problems because they're just so practical. You might actually do this someday in your life. Let's look at the first example. A 6-ounce cylindrical can of cat food contains a volume of approximately 16 pi cubic inches. How should the can be constructed so that the material made to make the can is a minimum? That should probably say needed to make the can is a minimum. And so this is a real, engineering question. You work for this company, and they make some product, and they want to make the most profit on this product, and so they need to minimize the cost. They need to minimize the amount of material used to make this product. So when we're talking about a can, the material that I use is the surface area of that cylinder. I need the top, the bottom, and the side that wraps around. And so what I'm trying to do is minimize the surface area, and my surface area consists of the top of the can and the bottom of the can. There's a radius here. We'll say that's radius R. And so there's a top and a bottom, so there's two. The area of each one is the area of a circle, which is just pi r squared. And then I've got this section of the can. If I peeled it off and stretched it out, it would just be a rectangle, right, of some height. And then the length of that would just be the circumference of my circle, right? So it'd be the circumference, which I know is pi d, which I know is 2 pi r. Trying to minimize the number of variables I use here. So surface area, I add to that the rectangle, which is 2 pi r, that's my length, times my width, which is height. And now I've got a nice equation here for the surface area. And I want to know, where is that a minimum? I want to minimize the surface area. And we know from earlier, if I want to find the minimum of a function, I need to find its derivative and set it equal to 0. I need to find my critical numbers. And then I can do, first derivative test, second derivative test, if I need to figure out which one of those critical numbers will give me a minimum. Now, before I can go on here, if I'm going to take the derivative of this, I just need one variable. Right now what I have is I have an r and I have an h. That's going to get tricky if I start trying to take the derivative. I need to get down to one variable or another, which means that I need to have a second equation. And so I need to go back to the problem and look for some other piece of information that I can use to make a second equation out of. And here's what I see. It's got a volume of 16 pi cubic inches. I know the volume of a cylinder is going to be its base times the height, and I know this is equal to 16 pi inches cubed. And so here's an equation that I can use to solve for h. I could get rid of r or I could get rid of h. Because my r's are squared, I kind of don't want to mess with those, so let's solve for h and get rid of h. I have that h is equal to 16 pi over pi r squared. Pi's cancel out, and so I can say that that's 16 over r squared. I'm getting crowded here, so let's go to the next slide. So my surface area is 2 pi r squared, and I'm going to replace that h with 16 over r squared. So this gives me 2 pi r squared. Oh, that's just getting worse. That's a pi. 2 pi r squared plus 2 times 16 is 32 pi. This r will cancel with one of those, so I've got an r in the bottom. I'm getting ready to take the derivative, so let's go ahead and move it to the numerator and make the exponent negative. I've got a nice function, I've got one variable, I'm ready to minimize it. So let's find the derivative of the surface area with respect to r. It's my variable. So 2 pi times 2 gives me 4 pi, subtract 1 from my exponent, leaves me with r, and then minus 32 pi r to the negative 2. And I need to set this equal to 0. going to go ahead and start solving this. I'm going to move this term to the other side. So I have 4 pi r equals positive now 32 pi r to the negative 2. I'm going to go ahead and move that back down to the denominator and make it positive because I don't really know what to do with negative exponents there. I need to get it out of the denominator, so I'm going to cross multiply over here. And that will give me 4 pi r cubed equals, I was left with 32 pi. Get the r term by itself, divide both sides by 4 pi. 32 over 4 is 8. My pi's cancel out, and so I've got r cubed equals 8. If I take the cubed root of both sides, I end up with r equals 2. 2 is a reasonable answer to get for a radius. I don't have multiple values that I could search for. You know, I don't have to do a second derivative test. I don't have to really do a first derivative test because I've only got one answer. If I had ended up with multiple r values, then I would have made a table and done a first derivative test to find out where a minimum was, because this could be a maximum. But in the context of the problem, I think we're safe in assuming that this is my only reasonable answer. And so I need to go back and reread the question and make sure I actually answer the question. It says, how should the can be constructed? And so I think it would be a good answer to give them a radius and to give them a height with which to construct this can. So I have the radius, and then I had this equation for the height. So the height is 16 over r squared. If I have an r value of 2, then that's 16 over 4, which is 4. So I think a good final answer would be to say use a radius of 2 inches and a height of 4 inches. Nice real-world problem. I like that a lot. Let's look at another problem. I like these problems too. You'll see these a lot kind of in math riddles. They're also, you know, kind of cleverly disguised on ACTs, SATs, things like that, to see if you can systematically solve them instead of just guessing and testing. Let's look at this one. It says, find two numbers whose sum is 10 for which the sum of their squares is a minimum. This is a very classic math riddle. But we don't have to sit here and guess and test different values. I could sit here and guess, oh, what's 1 and 9, what's 2 and 8, 3 and 7, etc. Or I can just do some calculus and get the answer directly. I want to find the sum of I want to find two numbers whose sum is 10. So let's call my two numbers x and y, and they add up to be 10, for which the sum of their squares is a minimum. So if I add these up, I'm going to get some number, and I want to minimize that number. That was supposed to be an arrow. That was better. I want to minimize that number. I know that to minimize something, I have to take its derivative, find its critical numbers, etc. And before I can take the derivative, I need one variable. So I could choose either x or y, doesn't matter. Let's get rid of the y. So I'm going to solve this top equation. Say y equals 10 minus x. And then I'm going to take this and plug it in here. So this is x squared plus 10 minus x squared. I've got one variable. I'm ready to take the derivative now. C prime is 2x plus, I've got a chain rule here. So on the outside, I have 2 from the inside, and then taking the derivative of the inside is just negative 1. And then I can set this equal to 0 and solve for x. So I have 2x minus 20 plus 2x. I think I got all that distributed right. So it looks like we've got 4x minus 20 equals 0. And then that means 4x equals 20, or x equals 5. Go back, reread the question, make sure you finish answering it, find two numbers I have an equation now to get my other number. If x is 5, if I do 10 minus 5, that means y will also be 5. And so my final answer for my two numbers are 5 and 5.